In the previous lesson, we studied about some of the basic building blocks inside a CPU and how those building blocks are used to execute a particular operation. We looked at the addition operation with much more detail to see how we could even implement a digital logic circuit to implement such an operation. Now let's put those concepts into action and see how we can build a complete CPU that can run software. You already know that software is a series of statements. When you write a software, you write a series of statements. Each statement tells the computer to do one particular task, and the computer executes these tasks in the order provided to get some useful work done. When it comes to the CPU, the statements are actually instructions from the CPU's instruction set. Each statement or each instruction will tell the CPU to do one particular task, very often a very primitive or elementary task like adding two numbers or comparing two numbers, loading something from memory to CPU, and then storing results back to memory or output devices. These instructions and the data that those instructions used to operate on are usually kept in the computer's memory. Both the program or the instructions and the data, they are in the computer's memory. And the CPU brings these instructions one at a time into the CPU from memory and then execute. So it will bring the first instruction, then execute that, and then it will bring the second instruction, then execute that. So one instruction at a time. This particular architecture is commonly referred to as the single instruction, single data architecture, or SISD architecture, which simply means that at any given time, the CPU take one instruction and the data associated with that instruction, execute that instruction, and then go to the next instruction. So usually when it goes to the next instruction, that will be the next instruction in the sequence that we are given. So the CPU will normally execute instructions in the order at which they appear in the memory. But there can also be some special instruction, if you recall our previous lessons discussion, like the jump instruction, which will ask the CPU to go away from that order and get the next instruction from somewhere else. So unless there's a jump instruction, the CPU usually keep on executing in the correct order. So CPU has internal mechanisms to keep track from where it should bring the next instruction. Now in all these cases, it is very clear that when the CPU executes instructions, it has to work very close with the memory. It has to bring both instructions and data from the memory for execution, which means the memory becomes the most highly interacting module in the computer with the CPU. So before we look into more details about how the CPU is structured and how it is designed to operate these instructions, let's look a little bit more about how the CPU would interact with the computer's memory.